The University of Bristol is home to the largest paleontology research group in the UK. And in this video, we're giving you a chance to peek behind the scenes and accompany us as we head to a nearby coastline in search of fossils.
Hi, I'm Rhys, and I'm the Engagement Officer for the Bristol Dinosaur Project, a paleontology outreach initiative organised here at the University of Bristol. I'm currently in the Wills Memorial Building, which is the home of the Earth Sciences Department and our extensive fossil collections.
Visitors to our foyer are greeted by our Smilodon skeleton from the La Brea tar pits of California. And a little further down the corridor is a sight familiar from the Jurassic Coast, a nearly complete ichthyosaur skeleton. With its 215-foot tall limestone tower, labs, social and teaching spaces, this building is certainly an impressive structure. But it isn't the only place where the paleontology team in Bristol operates. Just up the hill behind the Wills Memorial Tower, you'll soon reach the Life Sciences building. Completed in 2014, this impressive modern structure is the home of much of the paleontology department today. From undergrads and master's students to PhDs, postdocs and professors, there's a lot of incredible new research being done here.
Hi, I'm Liz and I'm the lab manager here in the Palaeobiology group at the University of Bristol. I did my PhD on pterosaur mass estimation and biomechanics. Paleontologists here work in a multitude of different labs, including wet labs for dissections and taphonomy experiments, a CT scanner for revealing the hidden details of fossils, and a state-of-the-art tomography lab where our students and researchers can visualize their data.
Hi, I'm Sarah and I'm a paleobiology master's student and I'm doing my project on ichthyosaur feeding mechanics and paleoecology.
Having access to these awesome labs gives our students a chance to view and analyse their fossil specimens in a way that was impossible even just a few years ago. Amazing though it is to be able to use these facilities and work in a building with such fantastic views over the city, modern paleontology isn't entirely lab-based. Fieldwork remains a crucial element of the science, and our local area is certainly not short of places we can go looking for fossils. We recently took a few members of our paleontology family across the channel to Penarth on the south coast of Wales. This is the Bristol Dinosaur Project on location. The fossils you typically find in Penarth can be dated to about 200 million years ago. That puts them at the very end of the Triassic period and into the earliest stages of the Jurassic. Starting from Penarth's iconic Victorian pier, we began our adventure by heading west, past the seawall, hunting for fossils along the shore leading to Lavernock Point. This area is no stranger to great finds, having been the site where the very first Welsh theropod was discovered in 2014. The animal, named Dracoraptor, is probably the best known fossil discovery from Penarth, and you can see its fossilised remains in the National Museum of Wales in Cardiff. But before we get too lost in all the fossils you can find along this beach, it's probably time we introduced you to a few of the paleontologists who came on our trip.
Hi there, I'm Will and I'm studying MSc Palaeobiology at Bristol University, and I'm researching how mammal shape changes in regards to body size and forearm mobility.
Hi, I'm Phil. I'm doing MSc Palaeobiology at Bristol, and my thesis is on evolution of early mammal relatives, comparing their jaws to determine why the lineage that eventually produced us succeeded over competitors.
Hi, I'm James, and I graduated from the University of Bristol studying paleontology. My interest was looking at dinosaur jaws. I'm now a paleo artist, and I work in outreach as well as being a lab technician.
So, what kind of fossils can you usually find at Penarth? Some of the most common are shelled marine invertebrates, like the famous ammonites, and familiar bivalves. There's also a chance you might find the remains of large marine reptiles too. But there's more than just those classical fossils on this beach. Alongside the pebbles are some geological structures which can give a fascinating glimpse into what the environment might have been like during the Mesozoic era.
Typically, whenever you go to the beach today, you'll see ripples forming due to the tide and the movements of the water. And all we've got here is a section of those ripple tides that have been preserved in the sediments. Ripples like these show us that, at this time in the Mesozoic era, Penarth was part of a shallow sea system, and incredibly, we can even tell the direction of the prevailing current. The ripples raise themselves up here, and they fall down this way, showing that the current was sweeping across the paleo surface here. But more than just ripples, the surface is covered in desiccation cracks. These geometric features are formed when sediment dries out and shrinks, giving us an indication that the sea levels were changing. And what's interesting furthermore about these desiccation cracks is we can see that they're raised, which means that these are actually the infilled moulds of the cracks that used to be there. And this is just a really good example of how we can infer processes in a paleo environment.
Sedimentary structures like ripples and desiccation cracks can be found all over beaches like this. But what about those fossils we came to search for?
So what you've got here is a bivalve, Pectinatus. Bivalve's a somewhat common fossil around here, so I am told. There's a particularly strong ribbing on this specimen.
Thanks to their large numbers, hard shells, and long evolutionary history, bivalves are one of the most common fossils you'll find on hunts like these.
Everyone does love a good bivalve, but for many the fossiling dream is to find something from some of those larger beasts which ruled the Mesozoic seas.
You want something?
That, I believe, is a vertebra. So this is a backbone belonging to a marine reptile of some kind, size-wise, probably a plesiosaur. So plesiosaurs, if you've ever seen a picture of the Loch Ness Monster, most of them are based on plesiosaurs. It's a large marine reptile with generally a long neck and paddles. These things were predators, like really quite formidable creatures. Yeah, it's quite unusual to find a big one like this. I'm really pleased actually. That's in very nice condition. It's broken a little bit on the side, but still, I think that's a good find.
Well done, James.
Thank you. So you notice, despite how great this fossil is, I didn't need to break any rocks open to find it. It was literally just there. It had already been eroded out. Nature had done it for me. Now, it can be useful to have a hammer with you, but your eyes is still usually your best tool. You don't have to break open every rock you see. But, you know, if you want to, it can be fun.
A lot of fossils can actually be found like this, laying out clear to see, like this huge piece of fossilised wood. Preserved with a shiny black lustre, fossil wood like this is often fragile and likely to break apart if not handled with care.
So, heading back towards the Penarth Pier, fortunately I came across this section of rock here, which luckily has preserved what looks like a bit of bone. So when we look at this bone here, it's likely that this came from a marine reptile, either a plesiosaur or an ichthyosaur.
After our finds here, we moved east of the pier, following the shore towards Cardiff. The cliffs here are even more spectacular, towering high above the beach with plenty of rich red mudstone. However, cliffs like this are naturally very dangerous, as is evidenced by the heaps of fallen rock, so safety here is always paramount.
So now we're on the other side of the pier, and in this part of the beach, the fossils that you find here are more like invertebrates. You're not going to find as many bones, but a lot of things like shells. And I've got two of these right here. And these are both mollusks. They're different types of mollusks. They still look quite similar. One of these, so the scientific name for this is a Gryphea, but it's got a more entertaining common name called a devil's toenail. You may have heard of these. This one, its scientific name is Plagiostoma, but it's a bit more like a big clam.
As we've seen, many fossils are already exposed, but others require extra work.
Sometimes you get a rock which looks like it hasn't got anything in it, but appearances can be deceiving.
Hidden fossils can be exposed with a good hit of a geological hammer, cracking the rock along natural weakened fault lines. This particular ammonite seems a bit stretched because it's been deformed in the rock after fossilisation, which is a common process. Though, hammering open a rock is no guarantee that the fossil revealed will be perfect. One of the best ways to find fossils is to search for regular shapes and contrasting colours in a world of random pebbles. But don't forget to look up every now and then. as when you're out and about you might well spot some more modern natural discoveries. But even if you aren't having great luck with finds in the rock, there's one set of impressive fossils you can always find here.
That is not breaking, is it?
Near the end of the sea wall, you can see some peculiar depressions in the bedrock. Alone they may not look like much, but step back and there's a clear series leading to one obvious explanation. They're footprints. These footprints were made 200 million years ago by a dinosaur walking across the muddy shoreline. And though we don't know for certain which species made them, it seems they were certainly a lot bigger than Dracoraptor. Because those footprints are so large and embedded in the ground, unlike many of the other rocks on the shore, those ones aren't going anywhere just yet. And with plenty of new fossils washing out of the cliffs each day, maybe one day we'll even find the animal who made them.